All right, here we go. Now, today we're going to talk about the properties of rhombi and squares. All right, now remember, every square is also a what? Rhombus, but not every rhombus is a square. All right, because again, the rhombus is simply, just think of a square that's tilted. All right, that's all it is. All right, so the main difference between a rhombus and a square is that the square has 90-degree angles. All right, so here are the properties. All right, and it's really simple to prove. All right, but let's just talk about it. Now, in a parallelogram or in a rectangle, the diagonals were not perpendicular. All right, but for a rhombus and a square, the diagonals are what? The diagonals are perpendicular. All right. Now, the other thing that's just true, all right, is that each diagonal bisects the opposite angle. All right. Everybody with me on that? And again, that would not be that hard to prove either. All right. And the way you could prove that easily, look up, please, for a quick second. All right, so you can see what I'm saying. Look at triangle RMH compared to HOM. Everybody see that? All right. Now, because it's an isosceles triangle, everybody with me? The base angles have to be congruent. Is everybody with me on this? All right. So these are congruent. So these have to be congruent. Is everybody with me? So now can you see that the triangles are congruent by side, side, side? Therefore, this angle is congruent to this angle. All right? Corresponding parts of congruent triangles are congruent. Everybody with me on that? All right, so it's really easy. Even if you don't know what the rules are, it's really, really, really easy to figure that out.
So the only difference between the rhombus and the square is just the angles?
The 90-degree angle. That's exactly right. All right. So now, again, I want you to remember the diagonals are perpendicular, and the diagonals in this case bisect the angle. All right. For a rectangle, that's not true. For a parallelogram, that's not true. But for the square and the rhombus, it is true. All right. So now let's take a look quickly at these exercises. All right. Now it is a rhombus. So because it is a rhombus, we can mark it. I think would be nice. And then I think the other thing that's nice to mark when they tell you a rhombus and they draw the diagonals, that those are perpendicular, which forms 90-degree angles. All right. And then if you want, you can get in the habit of saying this. Those are all equal. All right. And up here, you could say 1, 2, 1, 2. And up here, all right. So we could actually show that all four of those triangles are what?
Yeah.
Yeah. All right. All four of the triangles. All right. So with that, yes.
All four is...
Of course not, because one's obtuse, right?
Oh, yeah.
Right? And one's acute. All right. For the square, listen, for the square, that would be true.
Okay.
All right. For a square, that would be true. All right. But now let's answer the question. If angle ABD, if ABD is 60, then what is DBC? 60, right? Everybody with me? If AE is 8, then AC is 16. All right? If AB is 26 and BD is 20, what is AE? All right, so, well, let's look at it. So, if BD is 20, then this right here would be what? 10. Everybody with me on that? Yeah, and again, that's an a squared plus b squared equals c squared. All right, so it's a right triangle. So we would say a squared plus 10 squared equals 26 squared. Well, because didn't it say BD was 20?
Oh, yeah.
So then B has to be what? Has to be 10. All right. Now again, that's actually somebody made a good mistake yesterday. You cannot take the square root through addition and subtract. All right. You cannot take the square root through addition and subtract. All right. So you'd have to actually square 26. All right. And subtract from 10 squared. So a squared plus 100. What's 26 squared? What is it? 776 or something like that. How much is it? 676. That's what it was. Thank you. 676. Awesome. And so a squared equals 576. The square root of 576, I think, is 24. All right. So AE would have to be 24. AE would be 24. CEB is easy, correct? 90 degrees. Did I okay with that? And then if the measure of CBD if CBD is 58, then what's ACB? All right, so I'm looking for this angle, which is really easy because that's a right angle, right? So we have to add up to 90, so it would be what? 32. Very good. All right, 32 degrees. All right. Now, if AE is 3x minus 1 and AC is 16, then AE is also what number? 8. Thank you. All right. So now we can say 3x minus 1 equals 8, right? So x is 3. Thank you. Go back to that. Pretty straightforward. Pretty easy. All right. Now number 7. Let's go back here. Now they want CDB is 6y. And ACB is 2y plus 10. All right. Then this down here has to be what? 2y plus 10. Did I agree with that? And then those triangles have to add up to what? 90? Right? So we would say 8y plus 10 equals 90, so y equals what? Y equals 10. Any issues with that? All right. AB is 2x plus 4, and CD is 4x minus 4, and they are what? Equal, right? So 2x is equal to... You okay with x equal 4? Easy. I agree. All right, let's see what else there is. All right. So now, we have to determine whether the parallelogram is a rhombus, a rectangle, or a square. All right. So I think it's easy to graph these. Or I think it's easier to look at it, and then you can kind of decide how you want to move forward on whether it's a rhombus, a rectangle, or a square. All right. So let's go ahead and add that in. You tap on, see what I did? You see it? You tap like we're on page 2, so you just tap on it and it comes up. Tap on the page. All right. Now what I want to do is I'm going to, let's go ahead and just try number 1. All right, so let's graph those points and see what we're looking at. So in this case, we could have 0, 2, 2, 4, 4, 2, and 2, 0. All right, that's not that hard to figure out. That's a what? Everybody agree with that? Right, no, but we're going to figure out why it's a square. All right, first and foremost, what I would like you to do here, just for right now, is just draw the diagonals. I think the diagonals are easier to tell, or it's easy to tell. All right, so if you draw that diagonal, and you draw this diagonal, it's clear the diagonals are what? The diagonals are perpendicular. Is that okay with that? All right, so the diagonals are perpendicular. So that makes it a what? Automatically a rhombus. Or a, well, it automatically makes it a rhombus. Now we just have to identify whether or not it's a square. The bigger inch, right? So several ways to determine whether it's a square. All right. We have to determine what the slopes are. Do you agree with that? And if they are negative reciprocals, then we know it's perpendicular. The sides are perpendicular. So right now, the slope here is down 2 and to the right 2, right? Yeah. So the slope is -1, right?
Oh, yeah, I get it.
You good? Yeah, down 2 to the right 2. All right. And then if we want the slope of this up 2 and over 2, so that slope right here is what? +1. Therefore, the sides are also what? Are perpendicular. Therefore, it is a square, and it says, and it is a what? Rhombus. And does it say if it's a parallelogram? I'm sorry. If it's a square, it's also a what? It's also a rectangle. All right. So it's actually all of them. Square, rhombus, and a what? Rectangle. All right. It's telling you that it's a what? Parallelogram right off the bat. So bigger than that. All right. Yes. Why is the slope -1? Just because I went down 1 and to the right 1. From this point right here. I went down 1 to the right 1. Because I'm trying to figure out the slopes. How do you determine the things are perpendicular? The slopes are negative reciprocals.
But 1 is a negative reciprocal of -1.
What's the reciprocal of 1?
1 is yeah.
Okay. So we're good. All right, so now let's go ahead and try, let's just try 4. All right. Let's try 4. Let's graph these and see how this works out. -3, 0. -1, 3. 5, -1. That looks like a what? Looks like a rectangle. All right, so to prove that it is a rectangle, I just need to prove that the sides are perpendicular. Do you agree? Because we could look at this right off the bat and say, remember, I would draw the diagonals, and if you needed to, you could tell me what the slopes of the diagonals are. Okay, but those are clearly not what? They're clearly not perpendicular. All right. You can also say, if the diagonals are equal, then it's a what? A rectangle. Did I get on that? Did I hear me on that? If the diagonals are equal, it's automatically a rectangle. So you have an option. Do you want to do the slopes or do you want to do the diagonals? It makes no difference to you. You're going to have to show it one way or the other. All right? So let's look here. To me personally, the slopes, since we have it graphed already, the slopes are really easy. All right? So the slope is going to be up 3 and over 2. Is everybody with me? Yeah. The slope there is 3 over 2. Because I went from here up 3 and over 2. That's what I did. Now, I want it to be -2/3. So I'm just going to see if it's right. Down 2 and over what? Yeah, so the slope here is what? -2/3. So that automatically makes a what? A right angle. Am I good? And now just come over here and show me this is also what? -2/3. And show me this over here is what? 3 over 2. All right? So that shows me that all the angles are what? All the angles are perpendicular. So you create a perpendicular line. That's pretty easy. Then it's automatically what? All right? We know it's not a square because the sides aren't congruent. All right? That's very easy. Yeah.
I just don't understand. If you found the slopes.
I just found the slopes of the sides of the rectangle.
Why did you go to the bottom one? Why did you go to like halfway?
Because it doesn't matter if you go down 4 and over 6. -4, 6 is the same as -2. And I was just trying to prove that I'm right.
Yeah.
So I knew it would have to be -2/3. So I just went down 2, and guess what? Over 3 was on there. So I knew that was correct. Right? Okay, so now I want to go back and discuss this little proof right here. All right. So it says, write a 2-column proof given that that's a parallelogram and RS is congruent to ST. RS is congruent to ST. Wow. Super easy, correct? Because it's a parallelogram, what's true about RS and UT? They're congruent, right? Listen to me, guys. Let's just save us some time. You don't have to write this down. Just look up here and see if this makes sense. They're given RS is congruent to ST, right? So if we're going to prove this is a rhombus, we have to say that RS is congruent to UT. Why is that true? Opposite sides of a parallelogram are what? Are congruent. So now mark RS is congruent to what? UT. You with me? And now, RU is congruent to what? ST. Everybody agree with that? Same reason. Opposite sides of a parallelogram are congruent. And now, RS is congruent to ST is given. And then the next is just a substitution property. Is everybody okay with that? Right, that was very simple. Very simple. Oh, are you with me or not? Anybody have any questions? Yes.
Do I need to prove it with the diagonals are perpendicular?
No, I do not. And I'll tell you why. Because we already know that it's a what?
Parallel.
We already know it's a parallelogram. You with me?
But
If it's a parallelogram and all the sides are congruent, then it's automatically a what? It's automatically a rhombus. All right? Yes.
So your like proving thing would be that since RS and UT and ST and RU are all congruent, that's why it's a rhombus.
That's exactly correct.
And if it was, this sounds bad, but if it was like a rectangle rhombus, so it was like that's just a parallelogram, right?
Yes.
Because to be a rhombus, all the sides have to be equal.
That's exactly right. A rectangle is not a rhombus.
Okay.
All right?
But they're both.
Right. But if it's a rhombus could be considered a rectangle if the rhombus is a square.
Yeah.
All right. It's kind of tricky. No, you. Okay. So again, these are the kinds of questions that are on the test too. All right. So that's why I'm kind of trying to go through a little bit of what I did last year. All right. So if you have a square, that square could be called a rhombus and a rectangle because every square is a rectangle.
not all rhombus.
But not all rhombuses are squares, and not all squares are, not all rectangles are squares.
Yeah. But they're all parallel.
But they're all parallel.
Not all
Can a rhombus
rhombuses
be a rectangle?
And a rhombus can be a rectangle if the rhombus is a square.
Okay.
So a
No,
square can be a rectangle.
it's very annoying. All right, I
Is
totally
a
get it.
rhombus just like a tilted?
That's what I said. Think of it this way. Here's a square, tilted. That's a rhombus.
There's no 90 degrees.
That's exactly correct. Yes.
So basically, what I just see though is that it's a square instead of like. How does it prove that it's a rhombus?
How does that prove that it's a rhombus?
Because isn't the rhombus is different from the square, even though squares are rhombuses. So
So we don't know that the angles are perpendicular. That's why we can't say it's a square. We don't know that RU is perpendicular to RS. That's why it's a square. That's why it's a rhombus.
wait, how do we not know that since RS is equal to ST and ST is equal to UR?
Because the difference between a rhombus and a square are the
Are the
angles.
angles?
We don't know anything about the angles.
So we just can't prove that RSTU is a rhombus. We can't do that.
No,
No, we can't lose wrong. We can't lose square.
that's correct. We can't prove it's a square, right? It's the rhombus. Here's a square. That's a rhombus. The only difference between a square and a rhombus is the
It's
90-degree
tilted.
angle.
Yeah. So,
This is tilted.
but how do we prove that?
We didn't. We can't. We can only say that it's a square. We can only say it's a rhombus. We can only say that it is a rhombus. The only reason we can say it's a rhombus is because we proved all of the sides are equal. You understand that?
Mm-hmm.
But I can't say anything about
The angle.
the angles. So a rhombus is a square
So you don't need to prove
if it has 90-degree angles. Because we can't say it has 90-degree angles, we can't say it.
So so you don't have to. I thought that you had to prove the angles to prove that it was a rhombus.
No,
You don't have to do that.
no. You just have to prove the sides are congruent.
Okay.
All right. So now
No.
let's take a look at. Let's go ahead and take a look at this proof right here. Go down. Question number 7. All right. I'm going to let you do the math. I'll help you with the proofs. All right. So it says write a 2-column proof. Given RSTU is a parallelogram, and RX is congruent to TX. So RX is congruent to TX, and SX is congruent to UX.
But TX is equal to SX.
Oh, they're all equal to each other. I'm sorry. I wasn't reading that properly. You're right. Okay. So to prove that is a rectangle, what's true about the diagonals of a rectangle?
They bisect each other.
They bisect each other, but the diagonals of a rectangle are? No, definitely. The diagonals of a rectangle, they're congruent. Right? Good. I'm sorry. You're saying it so soft that I didn't read your lips very well. All right. So the diagonals of a rectangle are congruent. So if you can prove that the diagonals are congruent, then you can say that it is a rectangle. All right. So now our job is to simply prove that those diagonals are congruent, which is kind of obvious. All right. But we're going to go through that just to review. All right. So here we go. So we're going to write the given. Here we go. All right, so number one, we can definitely say is what? Given. All right. Now, let's take a look at step 2 now. All right, so for step number 2, all right, we're now going to have to use the what property? Yeah, but we have to say something first in order to do substitution. Segment addition postulate. Thank you very much. We have to do the segment addition postulate. So we have to say that Rx plus Xt is equal to Rt, and we have to say that Ux plus Xs is equal to Us. All right, so everybody needs to write that. Make sure you're good with that. And that's the segment addition postulate. Everybody good with that? Now, here it's just a matter of changing Ux. Ux is the same as what? Come on, guys. All I want you to do is listen. Let's get through it. Right, I'm going to now, please listen, change Ux to what? Rx, because they're equal. All right? So Ux becomes Rx plus, now I'm going to change out what? XS for what? XT. So Rx plus XT is equal to US, and that is a what? Substitution. That is a substitution. Do I go with that?
You have to say
Oh, they're all equal.
I don't understand.
No. That's what that statement says. But that I understand what you're saying. But that's all stated. You with me? They're interchangeable. Oh. So now I thought I made a mistake, but this right up here and this right up here is now another what? Substitution. You see that? So now for step number 3, we can say that RT is equal to what? US. And again, that's another what? Substitution. And then for step number 4, if the diagonals, so we would say that RSTU is a rectangle. And it's a rectangle because the diagonals are congruent. All right, that wasn't bad. Yes.
The Rx plus XT, is that the third reason or the third
No.
statement? Or
No, what I did here was,
isn't that substitution?
hold on a minute. Yeah. So, no, let me show you. Oh, yes, I'm sorry. Let me get this clear. All right. You're right. Sorry. Very good. 3, and this is 4. Sorry, and this is 5. I just totally mislabeled that. That's 5. Thank you very much. This is 4, and this is 5. All right, I don't think that's that hard. I don't think the proofs are that hard today. Owen, you still with me? All right. All right, so here's what your assignment is. Let's go ahead and come down. All right, I think we're good. With 6-5. Just do 6-5, practice, and just 1 through 11 is fine with me. All right. The kind of annoying ones are 9, 10, 11, but that's kind of a big section, all right, in this chapter. So make sure you do 9, 10, 11. I don't care about the tessellations, all right. We don't have time to do the tessellations. All right. Look over the proof. Make sure you understand the proof. And hopefully you understood the proof on number 5. All right, we have a short day today. There is no proof that we have to. All right, on this section. I didn't have the proof. All right. So again, on the agenda is the Chapter 6 test this week. I think it's either Thursday or Friday. Well, let's look real quick. Let me make sure I'm good. Let's look here at our lesson plans for this date. So tomorrow is 6-6. Yeah, Friday. All right, so we have one more section that I gave us 2 days. I don't think it's that hard. Just mostly just.
Are we doing another chapter?
Yes, I'm going to squeeze that in. All right. And part of the reason is because we have to get to the algebra 2 by the end of the year. All right.
Wait,
I've got
we
it.
like some guys.
Our,
Oh, yeah.
Oh, we
That's
do?
what I had
That's
last
what I
year.
did
I
last
took it like on a Thursday.
Yeah, we're going to do our exam probably at the end of the 3rd quarter, and then the 4th quarter is algebra 2. All right, so that kind of prepares you for your algebra 2. What?
What?
So we go into algebra 2 next year, but we've already learned.
Yeah, well, remember, algebra 2, the first semester of algebra 2 is just a review of algebra 1.
We're not taking it.
We're not taking.
We take the exam and then